Properties of real numbers. Let A, B, and C are real numbers. The addition properties. If A and B are real numbers, then A plus B is a unique real number. A and B are real numbers, then A plus B is a unique real number. Real number. This is the first property. The second property, if A and B are real numbers, then A plus B equals B plus A. The third property, if A and B and C are real numbers, then A plus B between parentheses plus C equals A plus open parentheses B plus C. The fourth property, if A is a real number, there exists a unique real number 0 such that A plus 0 equals 0 plus A equals A. The fifth property, for each real number A, there is a unique real number minus A, such that A plus minus A equals minus A plus A equals 0. Now we have how many properties? This is the first property. This is the second property. This is the third property. This is the fourth property. This is the fifth property. Let's now take the multiplication properties. The first property of the multiplication properties, if A and B are real numbers, then AB is a unique real number. AB is a unique real number. The second property, if A and B are real numbers, then AB equals BA. The third property, if A and B and C are real numbers, then A and B between parentheses multiplied in each other multiplied in C equals this A outside, and we open the parentheses, B multiplied in C. The fourth property is that there exists a unique real number 1 such that A multiplied in 1 equals 1 multiplied in A equals A. The fifth property is for each non-zero real number A, there is a unique real number 1 over A such that A multiplied in 1 over A equals 1 over A multiplied in A equals 1. In the addition properties, if A and B are real numbers, then A plus B is a unique real number. This is known as the closure property. Also, in the multiplication properties, if A and B are real numbers, A, B is a unique real number, is a closure property. Okay? In the addition property, if A and B are real numbers, A plus B equals B plus A. This is known as the commutative property. Commutative property. Also, in the multiplication, if A and B are real numbers, then AB equals BA is the commutative properties. Okay? Also here commutative. This is closure and here closure. Okay? The third property, if A and B and C are real numbers, A plus B plus C, to A and B between parentheses, equals A plus B and C between parentheses, which is this property known as associative property. It is also here associative property. If A and B are real numbers and C also is a real number, A multiplied in B between parentheses multiplied in C equals A open parentheses B multiplied in C. This is known as the associative property for both, for the addition and for the multiplication. Here there exists a unique real number 0 such that A plus 0 equals 0 plus A equals A. This is known as the identity property. Identity property. Okay? And also in the multiplication there exists a unique real number 1 such that A multiplied in 1 equals 1 multiplied in A equals what? A. This is also known as the identity, but it is in the multiplication. The fifth properties of both, for each real number, for in the addition property now we are reading, for each number A there exists a unique real number minus A such that A plus minus A equals minus A plus A equals 0. This is known as the inverse property. In the multiplication, for each non-zero real number A, there exists a unique real number 1 over A such that A multiplied in 1 over A equals 1 over A multiplied in A equals 1. This is known as the inverse property of multiplication. Now there is a common property that is common between addition and multiplication. That is, if A and B and C are real numbers, then A multiplied in B plus C equals A multiplied in B plus A multiplied in C. This is called the distributive property. It is common between multiplication and addition. Now let's take an example. Identify the property of real numbers illustrated in each statement. The first statement says 2A between parentheses multiplied in B equals 2 multiplied in AB between parentheses. This is called the associative property of multiplication. The second question, B, 1 over 5 between parentheses multiplied in 11 is a real number. There is a multiplication only, so the property should be in multiplication. This is called the closure property of multiplication. The third question, question C, we see here there is a multiplication and addition is involved. Okay, so when do we have the multiplication and addition involved, we may think of the distributive property. Okay, 4 multiplied in x plus 3 is 4x plus 12, which is the distributive property. The fourth question is D. As you can see, only addition here is involved. Okay, 5b here remain the same, only addition. This is A plus 5B between parentheses plus 7C equals 5B plus A between parentheses plus 7C. This is called the commutative property of addition. The fifth question, E, half multiplied in 2 between parentheses multiplied in A equals 1 multiplied in A. This is called the inverse property, as you see here, the inverse property. 1 over A, if you remember, multiplied in A. This is called the inverse property. Then it is eventually here equals 1. The inverse property of multiplication. Now let's go to the sixth question, which is F. Before that, please note that if you write the inverse, you have to identify whether if it is multiplication or addition. Also, the commutative should be noted whether if it is addition or multiplication. The distributive property is common, so you don't need to write multiplication or addition. No need for that because it combines the two operations. However, in other operations such that the closure, commutative, associative, identity, and inverse, you have to identify whether it is an addition property or a multiplication property. Now let's go to question F. 1 multiplied in A equals A. This is known as the identity property of multiplication. The last question, G. 7 multiplied in A plus B between parentheses equals 7 multiplied in B plus A. What did we do? We only swapped B and A. So this is known the commutative property of addition. The commutative property of addition. And we are done. It's important to note that every step in the simplification process depends on one property of the real numbers. For example, if I tell you simplify 7y multiplied in 2, you may write it's equals to 14y. What did we do to simplify? What did we do to get to 14y? We have made two operations. The first operation, we took 2 here and multiplied it by 7y. So we swapped. Okay. The second operation, we took 2 here, multiplied it by 7, okay, and into y, and we get the final result, which is 14y. Okay, this is the final result. So what is this property? This property is known as the commutative property of multiplication, and this property is known as the associative property of multiplication. So every step in the simplification process depends on one property of the real numbers. However, we are not going to mention that, okay, doing the commutative property, then we take 2 multiplied and doing the associative probability 2 multiplied 7 multiplied. No, but you have to know what you are doing. You have 4 properties for each in the addition and the multiplication, in addition to the common property, which is the distributive property that combines both operations of multiplication and addition. So getting back to our example, this is the commutative property of multiplication, and this is the associative property of multiplication. Another example, if I tell you 5x square plus 10x square. This is equal to 5 plus 10 all multiplied in x square equals 12x square. So what is this property? What is this property? I mean, what is this property compared to this one? It is the distributive property. It's exactly like multiplying x square in 10, which is here, and multiplying x square in 5, which is here. So it is the distributive property. That is the distributive property. And again, we are not going to mention every and each property. However, you have to know which property you are using. If you take any simplification in your way, when you simplify, when you are doing math, okay, take in consideration that every step in the simplification process depends on one property of the real number. So you have to know the properties of real numbers in order to simplify in the future. Now let's take an example. Simplify the given expressions a, b, c. The first one, 5 plus 3 multiplied in 2x minus 6. How to simplify that? Okay, this is equal to 5 plus, we can use here the distributive property, so it should be 6x minus 18, okay, which is eventually equal to 6x minus 13. We combined, of course, 18 and 5. So what did we do? We used the distributive property. The second question, 4x minus 2 multiplied in 7 minus 5 multiplied in 2x minus 3. If you remember, in simplification you start with the innermost symbols. This is the innermost symbol, so we have to decompose this. This is eventually equal to 4x minus 2 multiplied in 7. So we will use the distributive property here, so it should be 10x minus plus 15. Okay, we use the distributive property. So you don't have to write the distributive property unless if it is asked in the question. If it is asked what is the property, identify the property you are using, it's okay. However, in simplification you have to keep this these and other properties of real numbers in mind. If it is mentioned, simplify and mention the property, you have to mention it. But now for elaboration, I have written the property next to each simplification process I made. So this is eventually equal to 4x minus 2 multiplied in minus 10x, 7 with 15 plus 22. Okay, now we can use here also the distributive property. Also here use the distributive property to simplify. Okay, so this is eventually 4x plus 20x minus 44. What we have made, we multiplied here and here. So this is equal, at the end we combine the variables together, then this is equal to 24x minus 44. the third question without mentioning the property. Without writing the property, I have to write the answer. Okay, so this is eventually equal to 6 plus 3 multiplied. Start with the innermost parenthesis, so this is minus 2 multiplied in 2x minus, so this is decomposed in minus 12x plus 8. Okay, now combine x, the variables together. This is equal to 6 plus 3 minus 10x plus 8. So use the distributive property as well. So this is equal to 6 minus 30x plus 24. So 24 plus 6 is 30. So this is equal minus 30x plus 30. Now let's have a look at an equation. What is equation? What is equation? An equation is a statement of equality between two numbers or two expressions. That's it. An equation is a statement of equality between two numbers or two expressions. For example, between two numbers, if we say 3 equals 3, and between two expressions, if we say x plus z equals y plus 3, this expression equals this expression. This number 3 is equal to this number 3. So this is an equation and this is an equation. There are four basic properties of equality. Four basic properties of equality that relate to equations, which are A equals A. This is known as the reflexive property of equality. The second property is if A equals B, then B equals A. This is known as the symmetric property of equality. The third property is that if A equals B and B equals C, then A equals C. That is, if A equals B and this B equals C, then A equals C. C can be written here. So this is called the transitive property of equality. Property of equality. The fourth property, if A equals B, then A may be replaced by B in any expression that involves A. This is known as the substitution property of equality. Now we have four properties of equality. So an equation is a statement of equality between two numbers or two expressions. The properties of equality are four properties. The first property is the reflexive. A equals A. The second property, if A equals B, then B equals A, which is a symmetric property. The transitive property, if A equals B and B equals C, then A equals C. The fourth property, if A equals B, then A may be replaced by B in any expression that involves A, and vice versa. I mean by that, if A equals B, then B may be replaced by A in any expression that involves B. That's it. Now let's take an example that assists our understanding of the equality properties. The example says, identify the property of equality. The first question says, if 3a plus b equals c, then c equals 3a plus b. This is known as the symmetric property. The second question, b, says 5 multiplied in xy equals 5 multiplied in xy. This is known as the reflexive property of equality. The third question says, if 4a minus 1 equals 7b and 7b equals 5c plus 2, then 4a minus 1 equals 5c plus 2. This is known as the transitive property of equality. The fourth question says, if a equals 5 and b multiplied in a plus c equals 72, then b multiplied in 5 plus c equals 72. What did we do? We replaced a by 5. So this is known as the substitution property of equality. The fifth question says, if 4x plus 2y equals 7 and x equals 3, then 4 multiplied in 3 plus 2y equals 7. What did we do? We replaced x here by 3. This is known also the substitution property of equality. And that's it.